So in this video, we'll try to solve the problem of a fuel ratio. So calculate the theoretical fuel ratio of combustion of octane. So octane look like C₈H₁₈. So if it's combustion, so it's burning in the presence of oxygen to give you get carbon dioxide and water, right? So let's try to balance it. So I know that I have 8 carbon here. To get 8 carbon here, I can just give this let me give it some space. I can give this one 8. So but now here I'll have 8 by 2. I'll have 16 oxygen this side, and I'll have 1 oxygen this side. Okay, cool. Also the hydrogens here, they're 18. So to give 18 here, I'll have to give it a 9 here. But if the 9, this one will become 9, and then if I add these, remember these are oxygen, give me 25. So I want to have 25 oxygen this side. So we have 20, because there's already 2 here, I'll just have 25 all over 25 all over 2, which is 12.5, I think. So I don't know if I have to rewrite the whole thing proper now to be whatever, H18 plus 12.5 oxygen should give you 8 carbon dioxide plus 9 water, if that is allowed, water. But because the air that the oxygen that we are getting it, we're getting it from air, so air also contains some nitrogen. So remember, for every 1 oxygen we get from air, we also get some 3.76 nitrogen. So now, because we've got this much of oxygen, we should have got some much of nitrogen. So that will be 12.5 by 7 points, whatever. So I think we'll get 47 here. Good. So you have everything balanced out. It's not really balanced out if you argue, because this 47 nitrogen is not accounted this side. You can just put it both sides. Air is literally this thing and this thing. We are burning the hydrocarbon here in the presence of oxygen, and then we get that. So to make it look really balanced, I have to put these nitrogens both sides, because our air comes with like 21:79 ratio of nitrogen and oxygen. So we wanted to solve air fuel ratio, right? Air fuel ratio, it will be just I'm using mole ratio, it will be moles of air all over moles of should be moles of fuel. So air is made of like everything, of which is your oxygen and your. So I'm going to come here, nitrogen is giving me 47, should be 47 plus oxygen plus 12.5 all over what is here is just 1 all over 1. Then if we compute that, I think you should get 59.5 kilomoles of air all over kilomoles of fuel, octane in this case. Thank you.